Dear children, today's topic satellites. First one, geostationary satellites. If a satellite is made to revolve from west to east with a period of revolution equal to 24 hours in a circular orbit, concentric and coplanar with the equatorial plane of the Earth, its relative velocity with respect to the Earth will be zero. Such a satellite is called geostationary satellite. Here the satellites revolve from west to east and its period of revolution equal to 24 hours in a circular orbit, and it is concentric and coplanar, that is same center and in the same plane with the equatorial plane of the Earth. So its relative velocity, that is velocity with respect to the Earth, will be zero. Such satellites are called geostationary satellites. And these satellites appears stationary to an observer on the Earth. And these type of satellites are also called synchronous satellite because its angular speed is same as that of the Earth. Angular speed means when the satellites are revolving around the circular orbit, so its speed is angular speed and it is same as that of the Earth about its own axis. And because of this reason, these satellites are used for the communication purpose because its speed is same as the speed of the Earth. Telstar was the first communication satellite sent by USA into space in 1962. So we can define the geostationary satellite like this. A satellite which revolves around the Earth in its equatorial plane with the same angular speed and in the same direction as the Earth rotates about its own axis is called a geostationary satellite, or it is also known as the synchronous satellite. Clear? Then some uses of these satellites we want to see. The first use, it is used in communication purpose, in communicating radio, TV, telephone signals across the world. Then the second use in studying upper regions of the atmosphere. And the third one in forecasting weather, and the fourth one in determining the exact shape and dimensions of the Earth. Then 5 in studying meteoroids, and the 6 in studying solar radiations and cosmic rays. Okay. Polar satellite. A satellite that revolves in a polar orbit is called polar satellite. A polar orbit is one whose plane is perpendicular to the equatorial plane of the Earth. This diagram shows the Earth, then this is the equatorial plane, and the polar orbit is perpendicular to the equatorial plane, and this is the geostationary orbit. So geostationary orbit, that is the satellite moves from west to east. In the polar orbit, it moves from north to south and it is perpendicular to the equatorial plane. And it has the small radius. It is nearly from 500 to 800 kilometer. Okay. Then as the Earth rotates about its own axis, then the polar satellite passes over the different parts of the Earth's surface. So what happens here? Thus the polar satellite scans the entire surface of the Earth. Because of this reason, it scans the entire surface of the Earth. And some examples of polar satellite is given, that is the European Spot, and another one Indian Earth Resource Satellite. It is also in short form IERS. Okay. What are the uses of polar satellite? Used in weather and environmental monitoring, then used in spying or for military purposes. Then British polar satellite first detected hole in the ozone layer. Then one more used it to study topography of Moon, Venus and Mars. Okay. Weightlessness. What do you mean by this weightlessness? For example, when you place a book on a table, then the table exerts a force of reaction on the book. This force of reaction produces the feeling of weight in the book. So, if the force of reaction becomes zero, then the apparent weight of the body becomes zero. Now we can define this weightlessness like this. A body is said to be in a state of weightlessness when the reaction of the supporting surface is 0 or its apparent weight is 0. Now we can see some different circumstances in which the body can be in the state of weightlessness. First one, in a freely falling lift. You consider a person having weight mg standing in a lift which is moving vertically downwards with acceleration a. If capital R is the reaction of the floor on the man, here weight is acting downwards and the floor exerts a reaction force on the man. Then we can write mg minus R, that is the force exerted on the man or the person. It is equal to m into a according to the laws of motion. Mg minus R equal to ma. Therefore, R equal to m into g minus a. So, this is the apparent weight of the man. R is the apparent weight of the man. If the cable of the lift breaks, then what is the value of A? That is the lift moving downward with an acceleration due to gravity g. That is it is a freely falling towards the earth. That time A equal to g, then we substitute here, then apparent weight R equal to 0. So in this case, no force of action and reaction between the body and the floor. Hence, the man falling freely develops a feeling of weightlessness. So, when the cable of the lift breaks, then the lift moves downward with freely falling. So, in that case, the man falling freely along with the lift develops a feeling of weightlessness. Second one, at the center of the earth. As the value of g is 0 at the center of the earth, so weight of a body is 0 at the center of the earth. Okay. So at the center of the earth, the man feels weightlessness. Clear? Numericals. A satellite orbits the earth at a height of 500 km from its surface. Compute its kinetic energy, potential energy and total energy. Mass of the satellite 300 kg, mass of the earth 6 into 10 raised to 24 kg, radius of the earth 6.4 into 10 raised to 6 meter, g equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So here height of the satellite is given 500 km. We can write 500 into 10 raised to 3 meter. Then mass of the satellite is noted as small m and mass of the earth capital M. Then radius of the earth capital R. Then constant value g. Here first you want to find out the kinetic energy. So what is the formula of the kinetic energy? Kinetic energy equal to half mv square, where v is the orbital velocity of the satellite. We can write v equal to, already we derived the equation, that is v equal to root of g m by r plus h. That we can substitute here, that is half into m into g capital M divided by r plus h. Then we can substitute the values, half into, then small m, mass of the satellite 300 into, then capital G 6.67 into 10 raised to minus 11 into mass of the earth 6 into 10 raised to 24 divided by, then capital R 6.4 into 10 raised to 6, then plus h equal to 500 into 10 raised to 3. After calculating, we get the answer 8.7 into 10 raised to 9 joule. This is the kinetic energy. Second, you want to derive the potential energy. You know this equation, potential energy equal to minus capital G capital M small m divided by R plus H. Like this above equation, you should substitute all the values. Then we will get the answer minus 17.4 into 10 raised to 9 joule. Again the last one, you want to calculate the total energy. So total energy is equal to kinetic energy plus potential energy. If you know the formula, you can easily calculate or you can easily attend these problems. Then what is the kinetic energy? 8.7 into 10 raised to 9. Then minus potential energy minus 17.4 into 10 raised to 9. Then you will get the answer minus 8.7 into 10 raised to 9 joule. So this is the total energy of the satellite. Okay. Second numerical, find the potential energy of a system of 4 particles, each of mass m, placed at the vertices of a square of side L. Also obtain the potential at the center of the square. So before that, first you want to write this side AB equal to BC equal to CD equal to DA equal to L. That is given in the question. Then what is this AC and the BD from the figure? That we can write AC is equal to BD. Then according to the Pythagoras theorem, we can write AC equal to BD, that is root of L square plus L square in both the cases like that. So we can write root of L square plus L square, that is equal to root of 2L square. So we can write root 2L, root 2L, okay, root 2L. Similarly, we want to find out this OA, this distance OA, and this distance OC and OB and OD. All these distances are also equal. Then we can write OA equal to OB equal to OC equal to OD. That is equal to half of this distance. What is this distance or this distance? Root 2L. So root 2L divided by 2. That is equal to L by root 2. So this distances we get, okay, AC, BD, OA, OB, OC and OD. Then according to the principle of superposition, total potential energy of the system of particles, already we studied in the theory. That is the potential energy, that is U equal to, okay, total potential energy of the system of particles is represented by U, that is equal to potential energy between these 2 points, that we can write U, B, A, plus potential energy between these 2 points, that is U, C, B, plus potential energy between these 2 points, U, C, A, plus potential energy between these 2 points, U, D, A, plus U, D, B, okay, plus U, D, C. Okay. By adding all these potentials, we get the potential energy of the system of particles. So here, when you go through this, potential energy between BA, UBA is equal to UCB is equal to UCD is equal to UDA. So we can write that we can write 4 UBA. Why? Because here we can write UBA is equal to, okay, UDA is equal to UDC equal to UCB. So because of this reason, we can write 1, 2, 3, 4. So we can write U 4 UBA plus, then next one what? Potential energy between these 2 points, that is equal to, again we can write UDB, okay, UDB is equal to potential energy between these 2 points, that is UCA, okay, that is here These two are equal. So we can write 2 UdB. Clear? This is the total potential energy of the system of particles. Then we can substitute the formula for the potential. Again we can write U equal to 4 into, what is the general formula of potential? That is potential energy minus G M1 M2 by R. Okay. Once again, potential energy formula minus G M1 M2 by R. So here, instead of this M1 M2, what is here? M and M. And instead of the R, what is here? That is the L. So we can write 4 into minus G M divided by L. Similarly, plus 2 into, okay, 2 into UdB and Ca. So here also minus G mm, okay, minus G mm divided by, what is the distance between these 2 points? That already we find out here, that is the root 2L. So here we can write root 2L. Then substitution over. Then we can calculate the potential energy. So here from this equation we can take the minus 2 G m into m square, minus 2 G m square L outside, minus 2 G m square by L outside. Inside the bracket here it is 2. Then plus, then minus 2 G m square by L outside. What is remaining here? 1 by root 2. Clear? Again, minus 2 G m square by L into 2 plus, then here 1 by 1.414. Okay. That is, what is 1 by 1.4? Root 2 equal to 1.414. Then when we, that means divide, we get the answer, that is the 0.707. Otherwise, we can write one more equation here, minus 2 G m square by L into 2 plus 1 by 1.414. That is the value of root 2. So when you divide this one, we get the value of 0.707. So then after adding these two one and multiply with 2, we get the answer, that is minus 5.41 G m square by L. This is the value of total potential energy of the system of particle using the principle of superposition. Clear? Then what is the next one in the question? You want to find out the potential at the center of the square. So the general formula for the potential at the center is minus G m by R. Okay, minus G m by R. So we can write here total potential energy at the center. Okay, total potential energy or gravitational potential. Total gravitational potential. Okay, not potential energy, gravitational potential at the center O. What is the general formula? Minus G m by R. So we can write total gravitational potential V equal to potential at the point, that means at the center, potential at center O due to the mass at A and due to the mass at B and due to the mass at C and due to the mass at D. So the total potential at O V equal to VA, potential at the potential due to the point, due to the mass at the point A, VA plus VB plus VC plus VD. That we can write here, V equal to VA plus VB plus VC plus VD. So here we can write all these potential, that is equal, okay, equal distances. So these potentials are equal. So we can write 4 into VA equal to 4 into, we can apply the formula, minus G m by r. So instead of the r, we can write any one distance, OA, OB or OD or OC. So I am going to write here, that is the OA. Then we can substitute the value, 4 into minus GM divided by, what is the value of OA? We already written here, L by root 2. That we can write here, L by root 2. Clear? Then we can take the root 2 in the numerator. So V equal to, the last equation, V equal to 4 root 2 G M by L with a minus sign. So this is the gravitational potential at the center O. V equal to minus 4 root 2 G M by L. So this is the gravitational potential energy we already find out. Then the second one, gravitational potential. What is the general formula of gravitational potential? Minus Gm by R. Then what is the general formula of gravitational potential energy? Minus G M1 M2 by R. Clear?